about the state of Layer 2, hot topic. And Sandeep, co-founder and COO of Matic, is going to take us through all of that. So very exciting. Sandeep, are you there? Ready? Testing, testing.
So, perfect, yeah.
Okay.
Okay, so I can't share my screen. Could you give me the rights to share the screen? Simona?
Yeah, it looks like we'll just
okay.
update that permission.
I got it, yeah. Okay. Okay, I think, I hope my screen is visible. And
we're good to go.
Oh, yeah. Okay, so yeah, as Simona said, that very hot topic right now, where exactly is Layer 2 and, what exactly is happening in the space, especially with the crazy gas fees, on the Ethereum mainnet. So primarily, like the approach or the agenda for the overall discussion would be to have a look at the higher level parameters on which all like layer 2s are evaluated, and then I would like to go through the individual categories, that what all layer 2 approaches are being tried out currently, and which all projects are are kind of following those approach, and what is current status in some of those, right? So as this would be as per my current understanding, and I might have missed naming a few projects here and there. It is completely unintentional. Okay, so let's first get into that. What are the primary parameters for identifying layer 2s? So, one of the biggest thing that you would always come across is the data availability. By the data availability, I mean that when the off-chain execution, layer 2 chain execution, right? Something that is being executed off Ethereum main chain. So, the primary question for any layer 2 approach is where the data is being stored, right? So, and that's one of the key identifiers for layer 2. So for example, solutions like Plasma or Validum, or like any simple side chains, they would be storing the data off chain. That means the data is being stored by an off chain mechanism, and those mechanisms can also differ in their approaches. So for example, for optimistic rollups, which are kind of very hot right now, for them the data is actually stored on chain. That means the transaction data is actually stored on chain. So those are the kind of primary differences in terms of the data availability of the approach, right? Second thing is which is very critical, is that how are disputes or frauds detected or prevented, in the sense that, let's say you are having $100,000 on the side chain, or let's say the layer 2 has $1 billion in in the total value on the side chain, on the layer 2, and then the layer 2 actors decide to do something fraudulent, or some particular person or some particular user tries to defraud the layer 2 and tries to cash out more funds than they own on the layer 2 from the layer 1, that is the Ethereum main chain. Then how do you solve those disputes? How does the frauds kind of detected and kind of mitigated in that sense? So that is also like the second big area for judging a layer 2, right? So in that sense, like I found a very good this was a very good post from Starkware, where they kind of differentiated differentiated between validity proofs and fault proofs. So fault proofs is nothing but fraud proof essentially. So, and then on the y-axis they have the data, whether the data is on chain or data is kept off chain, and on the x-axis you can see that whether it's a like validity proof or fault proof, and then they have mentioned about which where you can identify a particular approach. So for example, Plasma, so your data of the layer 2, that means the whatever transactions are being executed, the data is being kept off chain by for a single operator plasma, or single operator plasma, like maybe like OmiseGo. There the data is being stored by the single operator, whoever is running, or a few parties that are running OmiseGo plasma. In case of, for example, Matic, have 100 plus validators who would be running that plasma, right? So they are storing the data, and many would ask that what is the need of a multi-operator plasma, right? So like example, OmiseGo, where a few people would be running, or like a single operator would be running the side chain where the transactions are happening, versus a Matic. So the answer lies in the data availability, right? So when we have since the plasma is storing data off chain, in this scenario, the data availability is being ensured. Like for Matic, why we feel that it's a better approach, and this can be debatable, and have been debated endlessly. But for us, we solve the data availability by building a robust POS set of operators. Instead of one operator running it, which can go down or can censor your transactions, here you have 100 plus validators running the plasma over a POS chain, right? So that's one way of thinking about it. Similarly, for example, optimistic rollups, as I explained, so there they use fraud proofs, and then I'll come to what is the difference between validity proofs and fault proofs also, like fraud proofs also. But optimistic rollups, so data is, as I said, the data is stored on chain, because you actually store all the transaction call data onto Ethereum, and then since the transaction data is on Ethereum, the fraud detection is much easier, because you're storing the transaction call data and the state root, and then if somebody wanted to sort of withdraw more than what they are owed, and then there will be a challenge period of, let's say, from 1 day to 7 days. Within that challenge period, somebody could come and based on the existing data, they can try to challenge that transaction, right? So that's what that's what happened with, let's say, optimistic rollups. Similarly, another category of these fraud detection or prevention is validity proofs. So in case of fraud proofs, you can think of it like somebody has run a fraud, and then challenge period, somebody can kind of come and challenge it, and then kind of slash or crypto economically penalize the faulty person who's trying to withdraw in a fraudulent manner. Instead of that, like, you have validity proof, which is again like very much debated, that whether validity proofs are better than the fraud proofs and all that. And the reason being that in validity proof, you, rather than having a particular transaction done on the main chain and then somebody challenging it, validity proof is at the time of withdrawal itself, you check whether this whether this transaction or whether this withdrawal has a validity or not. So that is slightly better. In case of ZK rollups, again, you have all the transaction data on chain. So in case of Validum, like Starkware, the data is off chain, managed by like what they call, I think they have a committee system where the data is stored by the off chain participants, and then on the main chain they run validity proof. So this is one of the critical areas like fraud proofs and detection mechanism. The third one, and the simple one, is that who is actually running the execution environment. Like I gave you an example of, let's say, somebody running a single operator plasma versus a Matic kind of environment where you have 100 plus validators running the the layer 2 execution environment. Similarly, you have like as I mentioned about Validum, there also you have a committee of people who are executing or running the layer 2 apparatus. To optimistic rollup, where the entire data is being stored on Ethereum, so you have full data guarantee, right? Data availability is completely secure. And in terms of data availability, there are multiple approaches, like lazy ledger, is being tested out by a group and all that. So yeah, so these three are the primary parameters. Then let's go into the approaches of what all approaches have been for the layer 2. So there, the most earliest approach that have been tried is state channels, where essentially you open a channel between two parties. You have some sort of guarantee on the Ethereum main chain. and then these two parties take the execution off chain, where let's say there is a chess game, so you have a 5 ether bet on that, so two parties will have a 5 ether kind of contract on main chain. Then we have we take the execution, and then we are playing the chess with each other, sharing transactions with each other. So you can see that the transactions are like basically just the signatures are being shared peer to peer. So scalability is really, really high over there. But then if something goes into a dispute, then we can bring all those transactions and then put them onto Ethereum, and then try verify that on Ethereum itself, and the Ethereum smart contract can identify that who actually was the winner or was going to win this thing, and they can settle the dispute. Problem is that the moment you take you do beyond of executions, then it's very hard to get all that data and put it into a smart contract execution, and then solve the disputes. So that is one problem. Then you have other problems, like what if the one of the two parties or both parties lose their, let's say they are playing a game on the mobile phone, and then there is some problem with the mobile phone, then the data is lost, and those kind of things. So that's why it has been like till now fairly hard to implement state channels in a very significant manner. Like I think CounterFactual, Celer, they have been toying with that approach. A Bitcoin Lightning Network, like I just mentioned it just to give an analogy, Bitcoin Lightning Network is sort of a state channel mechanism. Connext network is doing very good work with the state channels. They are kind of doing now, focusing on the interoperability between chains. So like for example, we are also working with Connext team where let's say from layer 1 to layer 2 withdrawals and deposits can be used via Connext state channels, so that they can be much faster. Currently, if you have to deposit onto, like, let's say Matic layer 2, it takes around 7-8 minutes because you need to have a confirmation on Ethereum main chain, then the sidechain actors need to do their consensus, and then you get the credit on the layer 2, right? So instead of that, you could use a Connext like state channel, which carries some liquidity. Similarly, it's actually more prominent on the withdrawal side, because in the withdrawal you have to wait for at least 30 minutes if you are using simple POS security, and around 7 days if you are using Plasma. So can ensure like almost instant kind of transactions for that. So that is like one I think upcoming use case of state channels. But apart from that, like apart from few games that are there on the Celer platform, state channels are still in that evolving approach, evolving kind of mode, and still like for production ready state channel systems, we are still we're still not there. Similarly, then there is a sidechain kind of mechanism where they can have a simple mechanism of running the consensus on the sidechain, and then you simply have a bridge between Ethereum, and then the assets can move to and fro between sidechains. But once the assets are on the sidechain, the problem is that once you have the assets on the sidechain, then the assets are fully in the custody of the sidechain actors. Like if sidechain actors decide to collude and then decide to do anything fraudulent, then you can't really do much with that. So for example, like, Loom network had the Plasma chain, POA network, was started like 2-3 years back. But, again, because it has a proof of authority, that means 7-8 validators are running the side chain, then, the system essentially becomes a trusted system. The same goes with the like XDAI system also. It's like almost like a POA, but then it DAI as the gas piece mechanism. So which is which provides slightly better user experience, but then the sidechain actors are few in number, 7-8, maybe 10 in number, and then they have to do a consensus on between them. And then if you are doing any deposits, withdrawals, your funds are at the custody of like 7 or 10 players. If you consider only the POS approach, like as I said that, and I'll cover it slightly later on, for example, for Matic network. So if you are developing something which only relies on the proof of stake security of Matic, then also Matic EVM chain will also become a side chain in that, like, in that sense you can think of it. But only difference that we feel is there, you have 100+ validators, less. This is also one more criteria, that whether the sidechain actors are permissionless and decentralized. So, in case of Matic, anybody can come in and become a validator on the sidechain. Whereas with POA or XDAI, it's a proof of authority kind of system, or kind of DAO kind of system. So DAO has to decide who can come in as a validator or not. So those are slightly the differences in that sense. This I already covered. Then Plasma. So in terms of Plasma, what is actually happening is that you have a sidechain kind of sidechain environment where the execution is happening on the sidechain itself. But then if when you are withdrawing, what Plasma has is fraud proof. So I also showed the same table, right? So when you are withdrawing, and in case there is a fraudulent kind of withdrawal, or the sidechain actors go rogue, and try to do fraudulent exits or something like that, then you can go to the Ethereum main chain and actually run fraud proofs, for example, and then try to slash the fraudulent kind of actors. So with Plasma, these are the two main things, like the assets, specifically the assets, or in case of Matic, you have something called predicates. So anything that is predicate enabled, whether it's a smart contract or it's a payment, with anything that is predicate enabled, for that you can actually, if you don't trust the sidechain, then you can go on to Ethereum and then challenge any particular transaction. And if you are able to successfully challenge it, then you get to slash all the people. Like in case of Matic, I told you that you have 100 plus validators and 66% of them have to sign it. So if, let's say, they signed on a fraudulent transaction and it became a checkpoint. So one important part of Plasma is also that whatever is happening on the sidechain actors keep checkpointing it to the Ethereum main chain. You can also think of them as a commit chains, right? So using that commit, if you don't trust the sidechain, or you kind of want to challenge it, you can go to Ethereum and you can challenge any particular transaction. And if you are able to prove it, in case of Matic, you get to slash at least 66% of the participants who actually signed on a fraudulent transaction. So that kind of provides you slightly more security. As I was already mentioning, OmiseGo doesn't have multiple validators over there. It has a few operators. I'm not sure whether only OmiseGo Foundation is running it, or there are a few external parties also. But essentially, you are like 2-3 participants are running, or few participants are running the sidechain. And then if something goes wrong, then you are essentially, there is some level of trust involved in the sidechain, because one problem is that what if the sidechain actor simply doesn't even share you the data, like this blind you that's called data withholding, right? So if they withhold the block data, then it might be difficult for you also to kind of go and challenge on Ethereum. So those kind of scenarios also emerge with like less operators. In case of Matic, again, I might be biased because I'm speaking from Matic network, right? So being one of the co-founders, but with Matic, we feel that having a multiple 100 plus validators, permissionless and WD decentralized, it's very hard for 66 of them to collude and try to do something fraudulent with the network. So yeah, that's one approach. Other part also is censorship resistance. So let's say if only few people are running the sidechain or the layer 2 apparatus, then there is a possibility that some of the few actors actually might end up censoring a few transactions, right? So if you have more decentralized actors on the side on the layer 2 apparatus, there is a possibility that there will be less degree of censorship, if at all, right? So that's about Plasma. One issue with Plasma that is always cited is mass exits. So mass exits is a scenario wherein let's say sidechain goes rogue, or maybe like the sidechain operator that I said, that if it is a single operator rogue, or in case of, let's say, Matic networks, let's assume in a worst case scenario all 66% of them go rogue, then everyone will have to exit their funds to the main chain, and that scenario is called mass exits, right? So, and it has been cited as one of the bigger problems in the Plasma design. And again, giving the perspective from the Matic side, like we believe that if you have larger number, like in this scenario 100 plus validators, the scenario where mass exit can be a reality is like almost like negligible, or like highly kind of mitigated. But let's say if you had less number of people running the layer 2 apparatus or running as operator, then it becomes like a significant problem, right? So that's why we believe that having is kind of secures that. And then Plasma has fraud proofs, I already said. Also, one more thing is that because you have to prove things on Ethereum, like with the fraud proofs, you essentially want to prove things on Ethereum. So if you have generic smart contracts, right, like an arbitrary smart contract, which let's say some DeFi lending borrowing platform smart contract that you have, it's you cannot have a direct, like a generic, like nobody right now, there is no generic fraud proof mechanism for every smart contract. So for example, in case of Matic, if let's say you have some standard operations, let's say fund transfers, dexes and all that, for all of them you have something we call predicates, right? So you have those standard fraud proofs for those standard use cases. But let's say you had an arbitrary contract and you wanted them to be fraud proof. That means you wanted them to be verifiable on the main chain. Then you need to write a specific predicate for it, right? So for example, we've been experimenting with Augur team, right? So building some fraud proofs alongside them, or predicates for the Augur kind of markets. And then I think with ETH Waterloo, I think Joey had also mentioned about them. So something like that. So in terms of the generic smart contract, even on Matic, although you have a EVM, but if you want to have your generic smart contract to be plasmafied, you could use like you could rely on the POS security of these 100+ validators. But if you wanted to use you wanted to have the plasma verification available on Ethereum engine, then you would have to write your predicates. That's one criteria over there. Now the rollups, which are like kind of younger in that whole category of various approaches, and they are also picking up a lot of traction because as we mentioned that mentioned about the data availability, because the data availability is on Ethereum itself. So there is more security for the, like, in case of fraudulent transactions and things like that. So primarily there are two kinds of rollups. There is one is optimistic rollup, and then there you have ZK, like zero knowledge based rollups. So in that sense, like Optimism is doing great work with the optimistic rollups, and recently many of you guys would have seen the launch of like the testnet of optimistic Ethereum, and Arbitum is also one a very important player there, and they're also doing some cool work. Plus you have other participants like Interstate. Accidentally I think I've not mentioned Fuel Labs. They are also like doing pretty cool work on that. So that's there. And in terms of the ZK rollups, I think Loopring is one of the biggest example. Again, that is not mentioned over here. Apologies for that. So for ZK rollups, Loopring is there. ZK Sync is also, I think ZK Sync is also building on ZK rollups. So those are the examples. Loopring and ZK Sync would be the examples of ZK rollups. And then from our side also, we also are exploring with various approaches around the ZK based solutions. But yeah, more on that later. With the rollups, you have higher Ethereum security. But then since you are putting all the transaction data onto Ethereum itself, then there are scalability limits, because you can only put certain amount of data on Ethereum, right? Essentially, you are running those transactions and you are putting all the data onto the Ethereum engine. Then, as of yet, I feel that, the developer experience is also not much sorted, because most of these solutions are still in the evolving stage, and none of the solutions is like production ready, except I think Loopring, which has a few applications, but I'm not sure how many third-party developers are building on that. But then Loopring has also been one of the more production-ready solutions. ZK Sync also, I hear few teams are using. And then like one of the other things is that till like very recently, optimistic rollups were used to be application specific. That means you have dApp specific rollups, and then that actually kind of hurts the composability side of things. But then if optimistic rollups are able to evolve into generic shared chain kind of rollups, that would be very interesting. And I believe Optimism and Arbitum team both are doing really working hard on that. And if that comes in, I think it would be pretty cool. And then one other part is that since the rollups are run by few parties, like 1, 2, 3, maybe 5 participants, then there is a higher chance of these parties colluding and then maybe doing censorship. So on the censorship resistance, I'm like yet to see more formidable solutions on that. There are some solutions proposed, but I've not seen a production or even theoretically a more kind of sustainable solution on that. So yeah. So lastly, like these 4 were the these were the primary approaches. Lastly, I would take like 4-5 minutes on explaining why what exactly is Matic network, and then how is it why it is getting so much traction. I'm pretty sure most of you guys would be hearing about a lot of applications building on Matic. Even now some of the DeFi protocols are also looking to build on Matic, and few of them actually went live recently. Got some good amount of in tens of millions of TVL. So what Matic is like, I was explaining that it is a hybrid proof of stake and plasma. Why I say so? Because as I said, that it's a multi-operator plasma. That means that means the like multiple operators, like this proof of stake network of 100+ validators, they are running the plasma Matic. So out of them, 66% of them have to sign on a particular checkpoint, and then it goes to Ethereum. And then having so many large number of operators, it also helps in terms of censorship resistance and more decentralization and the data availability, because we assume that if more than 66% of, like, it's very, very rare that more than 66% of the validators will collude, and it's very, very hard for them to do that. And I think like 100+ validators, it's almost like Cosmos kind of thing, which is a layer 1. So you have a layer 1 level of security on the layer 2 POS. So that makes it that's why many developers simply choose to build on the POS system, because it's much more developer friendly and user friendly. But then the solutions like which might have high amount of money involved in that, and they want Ethereum Ethereum security, they might use Plasma. Okay. Okay. So then developer, like one of the bigger benefits of Matic is that it's a full EVM based solution. So if you are building anything on this thing, and I would actually love to request or invite every one of you, like instead of, let's say, using a testnet, you could simply use Matic sidechain. Even on the main chain, you could run your entire application on the main chain and test it like hundreds of times, because right now the fees are like I think around 10,000 to 100,000 times, like 10,000 times less than Ethereum. So basically you can, in $1, you could do like maybe from 5,000 to 10,000 transactions. So you could actually, show your application running on main chain or maybe on our Mumbai testnet. Both are, and the good thing is that on Matic network, the transaction, the block confirmation times are 2 seconds only, right? So you could go to explorer.matic.network. There are more than 500,000 transactions that have been done by various applications, and the user experience goes, top notch. So I would like, love to invite all of you guys to use the Matic testnet as your testnet, because, the user experience and those things are much higher over there. And then, acquiring, test ETH from Coven, it's much easier on Matic to acquire, for testing. Right, so use it as the testnet and see what your developer experience is like, and then if you like it, then we would love to help you out. In terms of developer tooling, that is also one of the bigger benefits, that most of your developer tooling, which include like your wallets, your Web3.js, oracles. So Chainlink, for example, Matic is going to be the only second chain, I think, after Ethereum, where Chainlink is expected to launch their mainnet. The second chain after Ethereum, and then your Remix ID, your Ganache and your truffle, everything works out of the box. So that's why, like, I think it would be a great start if many of you wanted to try it on the mainnet or on the testnet side, and have a better user experience. And then already we are seeing the number is around, I think, 70 even now, and then 50 plus dApps, but safely are on the mainnet right now. The number of transactions also today would have crossed like 600k, 130k plus active addresses, and around $12 million in the TVL in the bridges. So for DeFi, for all of you who are looking to build DeFi based applications also for the hackathon, would love to connect with you guys. And then we have a very solid developer support program where if you have a cool product which you think that you can take it to MVP stage, we provide that developer from our side. And we also have a build and with Bitcoin, where we actually give out for early stage applications, right? So we give out like $50,000 monthly, one of the dApps, and that I think from the Gitcoin donation round, and one of the dApps I think they've got like around $11,000. So it's a good mechanism for you to kind of experiment in your with your application when you're early stage. And then we also help many of our applications recently, which are ecosystem applications. We help them to raise funds also, and then all those things. So if anyone of you goes to that stage after your hackathon and you want to reach out, please do reach out. We're there on the Discord side, right? So that's all from my side. Would love to take any questions.
Great, thank you so much, Sandeep. Actually,